Hello and welcome to AJP-Heart and Circulatory Physiology September Video Table of Contents, or from the editor's desk. As you can tell, I'm not in my office this month. This just goes to show you that you can access AJP-Heart and Circ from anywhere there's an internet connection, so there's no excuse for not browsing our table of contents. This month we have a great lineup of papers for you to enter into fall with. We published 4 reviews, 15 original research papers, and 2 editorial focus articles. I know you're anxious to get a preview, so here we go. In a review by Shibayama et al., evaluation of metabolomic analysis of the failing heart is discussed and reviewed. Metabolomic analysis of the failing heart has revealed global changes in mitochondrial substrate metabolism. A discussion of peroxisome proliferator activator receptor alpha, or PPAR alpha, as a critical player in synergistic regulation of cardiac metabolism through transcriptional control is nicely summarized. Metabolomic reprogramming via PPAR alpha signaling in heart failure ultimately propagates into myocardial energetics. This review summarizes the current knowledge of the PPAR alpha regulatory mechanisms in cardiac metabolism and the possible role of PPAR alpha in epigenetic modifications in the diseased heart. In addition, the authors discuss how metabolomics can contribute to a better understanding of the role of PPAR alpha in the progression of cardiac hypertrophy and failure. In a review by Chen and co-workers, the role of exosomal communication in the ischemic heart is discussed. This review focuses on beneficial exosome-mediated processes. They discuss in detail how to fully exploit the therapeutic potentials of exosomes in the field of ischemic heart disease. Topics include identifying robust sources of exosomes, loading protective agents into exosomes, developing heart-specific exosomes, optimizing isolation methods, and translating the cardioprotective effects of exosomes into clinical practice. Finally, both the advantages and disadvantages of using exosomes in clinical settings are addressed. Peterson et al. Review metabolic remodeling in the hypertrophied and failing heart. In this review, they discuss metabolic phenotype and metabolic signaling in the context of pathological hypertrophy and heart failure. They discuss the significance of alterations in energy supply and energy sensing using observations from human and animal disease models and models of manipulated energy supply sensing. Finally, they suggest that lack of metabolic flexibility and reserve represents a final common denominator, ultimately compromising efficiency and contractile reserve in stressful contexts. The last review in this issue by Bose et al. Describes sex-based differences in the physiology and pathophysiology of the vasculature, with a special emphasis on sex steroid receptor, estrogen and androgen signaling, and their potential impact on vascular function in health and diseases, such as atherosclerosis, hypertension, peripheral artery disease, abdominal aortic aneurysms, cerebral aneurysms, and stroke. Given the new NIH guidelines emphasizing sex differences in preclinical research, this is a very timely review. Mitra and Stern performed patch clamp electrophysiology from identified vasopressin neurons in acute hypothalamic slices obtained from enhanced green fluorescent protein vasopressin transgenic rats. Voltage clamp recordings showed that prorenin inhibited the magnitude of A-type potassium currents, a subthreshold voltage-dependent current that restrains vasopressin firing activity. Prorenin also increased the inactivation rate of A-type potassium channels and shifted the steady-state voltage-dependent inactivation function toward more hyperpolarized membrane potentials. Prorenin failed to increase superoxide production within the supraoptic nucleus and the paraventricular nucleus, and prorenin excitatory effects persisted in slices treated with the SOD mimetic Tempol. Taken together, these experiments indicate that prorenin's excitatory effects on vasopressin neurons involve the A1 current, due in part to increases in its voltage-dependent inactivation properties. Yusuf and co-workers investigated the contribution of KATP channels to aerobic basal cardiac metabolism. Hearts from KIR 6.2 wild type and KIR 6.2 knockouts were perfused. Despite cardiac mechanical function and metabolic efficiency being similar in both groups, hearts from knockout mice displayed an approximately twofold increase in fatty acid oxidation and a 0.45-fold reduction in glycolytic rates, but similar glucose oxidation rates compared with hearts from wild-type mice. Knockout hearts also possessed elevated levels of activated AMP-activated protein kinase, higher glycogen content, and reduced mitochondrial density. These data indicate that KATP channel ablation alters aerobic basal cardiac metabolism. The observed increase in fatty acid oxidation and decreased glycolysis before any metabolic insult may contribute to the poor recovery observed in knockout hearts in response to exercise or ischemic reperfusion injury. Finally, Toy et al. Evaluated the contribution of electrical remodeling and an arrhythmic phenotype in a myosin-binding protein C knockout mouse model that developed severe hypertrophy. Telemetric electrocardiographic recordings of awake mice revealed prolongation of the corrected QT interval in the knockout mice compared with wild-type control mice with overt ventricular arrhythmias. Whole cell current and voltage clamp experiments comparing knockout and wild-type mice demonstrated ventricular myocyte hypertrophy, AP prolongation, and decreased repolarization potassium currents. Quantitative RT-PCR analysis revealed decreased mRNA levels of several key potassium channel subunits. Thank you for watching the September video table of contents. Please visit the journal website and see all the great science that I could not have highlighted here today. There you'll find all of our current calls for papers and collections of previous calls. You'll also find the link to our great podcasts more than any other journal. We will see you next month, and don't forget, send us your best work now.